Hello, this is our third part of our binomial theorem lecture. And I wrote down the binomial theorem itself. Now, it's kind of overwhelming when you first look at it. It says a plus b to the n, and these little symbols here now should look familiar to you. These are the binomial coefficients. N0, N1, N2, and I know it looks very overwhelming, but what this is, when you expand a plus b to the n, where n is some positive integer, okay, it's going to create terms, okay, and the terms have what we call binomial coefficients, which we learned on a previous part to this, and the terms itself, the first term in the binomial is a, and the second term is b in this case. Now, a could be 2x, b could be negative 2y. So it is a term in itself. So you take the binomial and you expand it, and each one of them has a binomial coefficient. It begins with n0, n1, n2, and it ends with nn. And that should look familiar to you as well, because that's what Pascal's triangle had in a previous part as well. And but the terms themselves, they start with the first term in the binomial, and it begins with the degree n. That's the same as the degree of the binomial. And it starts decreasing it down by 1 from every term there on after. So it's a to the n minus 1, a to the n minus 2, and it goes all the way until there's no a's at all. Now b is that, but in reverse. There's no b on the first term. There's no second term on the expansion. It's first term expansion. But then it comes b to the first, b to the second, b to the third, all the way out to b to the n. It just becomes reversed. Okay? And remember, n is some positive integer. So I created a few examples of x plus y to the first, x plus y to the second, x plus y to the third, x plus y to the fourth. And I did these problems right here within just a few seconds. Now, x plus y to the fifth is actually x plus y times x plus y times x plus y times x plus y times x plus y. And if you had no theorem or anything to look at to expand that, you'll be there quite a while, because you'd have to FOIL x plus y out twice, then again, and then again. And then you get a list of a lot of terms. And so what we did was we created this theorem that actually simplified that pattern. Because if you, like I said, if you're going to multiply this out 5 times, you're going to be there a good 15 minutes at least. And so it takes a long time doing. And besides that, you're probably going to make a mistake in that process. And so I'm going to show you how I can come up with x plus y to the fifth, and I'm going to do it rather quickly. This is the x plus y to the fifth. If you expand that out, it's going to be x to the fifth plus 5x to the fourth, y to the first, plus 10x to the third, y to the second, plus 10x to the second, y to the third, plus 5x y to the fourth, plus 1y to the fifth. And that's the expansion of x plus y to the fifth. Now, I didn't do the multiplication in my head. What I was doing was I was following the theorem. Okay? If you looked at my x's, like I said again, it had x to the fifth. So by x to the fifth, x to the fourth, x to the third, x to the second, x to the first, and no x at all. And then y is that reverse. Y to the fifth, y to the fourth, y to the third, y to the second, y to the first, and then no y. Okay? And if you look at the degrees on every one of them, 4 and 1, 3 and 2, 2 and 3, and this one actually would be 1 and 4, they all add up to the degree of what n is, in this case 5. If you look at x plus y to the fourth above it, x to the fourth, x to the third, x to the second, x to the first, no x. Y to the fourth, y to the third, y to the second, y to the first, no y. Now the only thing is, now how did I come up with those binomial how did I come up with those coefficients so quickly? I mean the 5, the 10, the 10, the 5, and the 1. If you remember from our previous part, those numbers should look familiar to you, and that was on one of our rows of Pascal's triangle. And as a matter of fact, all these coefficients are actually my binomial coefficients that we talked about in the previous part. And if you remember, the binomial coefficient was 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. So, and if you notice, the coefficients on this expansion was 1, understood, 5, 10, 10, 5, and 1. Exactly the same numbers on that fifth row of Pascal's triangle. So if I was going to do x plus y to the 6, I think we can all do it now, because then I can look at all these coefficients. Those are going to be my coefficients from one term to the next. And so I'll have 1x to the 6th. The next one would be this coefficient, so it would be 6. And then bring the x down, the exponent down by 1, that's a 5. And now the y's come in because it's going to have to add up to 6. 5 and 1 is 6. And then the next coefficient is 15, so it'll be 15 x to the 4th, y to the 2nd. The next one's going to be 20, 20 x to the 3rd, y to the 3rd. And then the next one's going to be 15 again, x to the 2nd, y to the 4th. And I'm going to run out of room rather quickly. The next one's going to be 6, so it's going to be plus 6x to the 1st, y to the 5th. And then the last term of that expansion is plus 1y to the 6th. Okay, so that's what x plus y to the 6th is. Now, as you can probably guess, if I was going to do this manually, like you would have taught or learned in basically in Math 103, that expansion would take you forever to do. Either you'd give up, most likely most students would give it up, or they'll make a mistake in the process somewhere down the line. I don't care how smart you are. If you try to expand that out manually that many times, you're going to make a mistake. And if a mistake is made early, that's really bad, because everything else from then on out is going to be affected as well. And but usually that's, people would probably give up most of the time if they were going to expand this out 6 times. And because just imagine how many terms you'd have to have. 1, 2, 3, 4, 5, 6, 7. If you notice, there were 7 terms there, and it's x plus y to the 6th. And the one had x plus y to the 5th had 1, 2, 3, 4, 5, 6. So it appears, and it is the case, that you'll have 1 extra term than the degree. So if the degree is 5, you're going to have 6 terms in the expansion. If your degree is 8, you're going to end up with 9 terms in the expansion. It's just because that's what Pascal's triangle has. If you look at the third row, first, second, third row, there are 4 terms. Okay, so that kind of goes together. So I think now at this point you could actually do x plus y to the 7th, and even with the theorem itself, it won't be easy. I mean, it would take you a little while because we're going to have 8 terms, so it would just take a long time just to even write those 8 terms down. And when you do those 8 terms, you would have to go do the 7th row of Pascal's triangle. And this is where the binomial coefficient comes in, because this is going to get tiresome pretty quickly. And in the next part, I'm going to show you a couple of examples using the binomial theorem. One, when the Pascal's triangle is a good way to come up with those coefficients. And I'm going to show you one that when the degree is a little larger, you're not going to want to do that. So, but I'll save that for part number 4.